Hello? You can hear me, right? Okay. So, well, this week of course, we continue, but let us focus on our vision. Okay. So, if your daily life could be written as an optimization problem, okay, I would like to hear from you. What would your objective function be, and what would be your funniest or strangest constraint? First, objective function is maximize sleep hours. Okay, with constraint, you must attend all classes. Second, the objective function is minimize coffee cost, and the constraints are at least 3 cups per day. Okay, or objective maximize Netflix time with constraint assignments submit before midnight. Okay, so well, or you have other any other objective function and constraint in your life. What about you, Jeremy?
Spending.
Optimize.
Like spending we can have.
Yes. Any constraint?
Constraint like the nutrition must be fulfilled.
Okay.
Daily nutrition.
Okay. Ping. You can choose from here, or while you create objective function and constraint by yourself. Any constraint? No. Okay. สุธรรมฮะ Okay. Okay, so you try to minimize the time you spend for reading, okay, but still get full information. Okay, so any volunteer from here? Around here. From these 6 people? Yes, any volunteer? Yes? Mm-hmm. Okay, you have constraints? Yes, good. Okay. Yeah, or you can mix. Yeah. Try to maximize sleep hour and maximize the number of movie in Netflix. All right. So you see that we use optimization not only in in engineering problem, even daily life. Okay, we use optimization for our decision making. All right. So back to one moment. Okay. So this week we continue. Okay, we still focus on the problem formulation, optimization problem formulation, of course, new types of problems. But what are we going to do next? Last time we used Excel, right? This week, we will use Pimo, okay? And Pimo, and so on, okay? For those who cannot use Excel, you have 2 choices. You buy a new notebook, or you use Pimo, okay? I cannot help. I cannot debug the Excel, all right? So, and one learning outcome beside the Pimo, we formulate optimization problems with clear decision variable, objective function, and constraint again, okay? The carry from last time. And we model it and solve different type of problem, knapsack problems, and production planning problems in Pimo. Of course, you can try Excel, okay? Pimo or Excel, does not matter. They are tools, okay? And interpret optimization result and explain managerial insight from the solutions, okay? How you interpret the solution to real world problem. And again, we work collaboratively as a group, of course, to formulate, implement, and solve optimization problem. Okay, and this way we improve our teamwork skill. Okay, all right. So yeah, we start from primal first. Okay, then when I introduce you more complex problem, you can implement those primal. We start from very simple model. One moment. Okay. So this problem. No. Okay. So build your first primal model. If I tell you to maximize profit, this is our objective function. Very simple. 3x plus 2y. We have two decent variables, x and y. Okay. And we have two simple, no, only one simple constraint. X plus y must be lesser than or equal 4. Okay. And we have non-negativity constraint on x and y. And what else? How would you write that in primal? Okay. Very simple. If if you want to install Python in your notebook, just do it. You already have Python in your notebook. You can use it. But if you don't have Python in your notebook, I recommend you to use Colab. Colab. You may have no idea what is Colab. It's you can code and run Python on cloud on Google server. We call it Google Colab. You have access to internet, right? Yes, that is good. So you can start using Colab. And this is my model. Okay. If you scan it, you will see the skeleton. I mean the template. I made it in Colab. Okay. You can copy that because you cannot edit that file. Okay. If I allow you to edit that file, that cause problem. Okay. So you can duplicate that file to be your file. Okay. And start working on it. Okay. Try it first. If you have problem, just tell me. Okay. Then I will explain you the code. Or if you don't want to scan the QR code, you can type by yourself. Okay. This QR code and this link is the same thing. Okay. Yes, you can connect to Colab, Google Colab. Oh yes, that's good. So you please duplicate that file to be your file, okay? Because you cannot run in that file. It's a read only. Okay. I will show you mine. Okay, this is mine. Don't worry about this one. Okay, later once you run this block of code, you will get this. Okay. Okay. Everyone land at that pages, at that page. Okay. You can do it. Yes, that is Colab. Yes, that is Colab. So you see this three line. The first three line, acclamation and PAP install something. If you run it in Colab, you need this exclamation symbol. Okay. And each line, what is the meaning of each line? Of course, in this workspace, you can run any Python code. But we need library. We need Pymo. Pymo is not available there, you know. You see, acclamation, PAP install, Pymo. Okay. Beside Pymo, we need solver, GLPK, utils, and Koinoa CBC. Okay. So running this code. To run the code, you see this symbol, right? Just click on it and see what happened. We ask the Python interpreter to install Pymo, GLPK utils, and Koinoa CBC in our workspace. Okay. And remember that we run on cloud is temporary. If you disconnect it and later you want to run it again, you have to install every time. Okay. Because it's kind of temporary. If you run Pymo locally in your computer, you don't need this symbol, acclamation. Okay, just PAP install Pymo, PP or apt-get install, yeah, all this line. Okay, and you need only once because it's already installed. Okay, it will, well, your Python will download those packages and install in your computer. Okay, that man. So you see that, wow, it's already installed somewhere. What about our code? Okay, pay attention to this block. Import Pymo environment as higher. Okay. We just import that, what we install, Pymo. And we declare model. Model is, well, Pymo, concrete model. And we declare our detail variable. You see this block of code, right? Okay. We declare X and Y. Okay. As non-negative real number, non-negative real number, X and Y. Okay. And what else? We, well, declare our objective function
model.profit IO objective. Yeah, that is right. 3x plus 2y, right? Okay, and then we declare the concern, our concern. Okay, and this part is solver. It's we use CLPK. Of course, later if you need different solver, you replace this CLPK with other things. Okay, but start from CLPK first. Okay, and solver.solve model. Okay, if you change this one, you declare different name. Of course, you need different name, right? Okay, so then we print x value and y value, also profit the objective of this value. Okay, so we run this code. If you did everything correctly, then you will get result.
Then you get result.
But previously, Ajahn, when I use GLPK, it is not working. It is showing like this. Application error, cannot locate GL.
Can you go up? You install this one first.
Already did it. Because I already run this one.
And let it finish this part first.
Yes. Previously, I did.
What happened? Why
I-
the code is quite
Short.
short? Yeah. Happened to it. You can run it. Yeah. What happened? You try different solver. Okay. No. Yeah, that one. Okay, everyone got the same problem. Then you change from CLPK to CBC. Yes. You replace this CLPK with CBC, right? Can you solve it with CBC? Okay. One moment. Okay, just before you run the code, try this command first. Well, exclamation, which GLP sold? I want to check whether, wow, you already installed GLPK. You cannot run it still.
Still cannot use
The same like
this.
Yes.
But after run with GLP, then still cannot.
ชีวิตการเกี่ยวกับเกมไม่ได้ไม่ได้
มันเป็นที่ก่อนที่เขาโมเดลบอกเราแต่คนแรกมันเป็นที่อื่นไป
เพราะมันอยู่บนคลาวด์อ่ะแต่ว่าเกม Just one moment. Let me check if we have. Wow. Maybe we need to set this one. If you cannot run TLPK, check whether TLP server is available in your system or not. And then specify what is TLPK. Excuse me, yeah, this line. Okay. You can do it. Still? No?
Or I can see from the Google.
Yeah, you can see it right too. Okay. You can see from this Zoom. Yeah, you can see from Zoom. Just one moment. Oh, what? What is Zoom? Do you remember the meeting ID?
Yes.
Yes. What is it?
Take a picture.
Yes.
849.
H four nine.
Yes, 849. 727.
7 4
Yes, 2
2
7 4 7
4 7
1 8.
1 8. Correct?
Yes.
Okay. Yes. This meeting ID.
It is working now. GLPK. Yeah, it is.
I don't know why, but
Then two.
Progress.
อ๋อโอเคไม่น่าจะ ได้สิเอ๊ะได้แล้วแค่คือเวลาได้เลยโอเคnow you can run in GLPK okay so well mute your speaker first it will echo you see okay so well if you can run GLPK it's okay no problem or even CBC you can if you okay okay so if you cannot run GBRPK or CBC later you have to set the solver okay and this is the way we set the solver okay we check the location of GLP solve first by using this command which GLP solve okay then once we know the location of the command then we set this way just before you solve the problem you set opt yes option where the server is okay in case of CBC also if you cannot access the CBC wow check whether you install CBC or not if you already install it and you cannot use CBC you have to set this way USB user bin CBC something like that okay you set it before you run the server you see I set it in this block and then where is it okay in some block around here I sold okay again so why is it ping turn off your microphone mute your microphone you're mute okay good so okay this is basic how you implement your solver okay the PyMo the next one now you know right how to model if we change the decision variable and also here this block model X dot model Y yeah this is how we set the decision variables okay if you have more decision variable you set here okay and yeah this one non-negative reals what does it mean it's a non-negative number it's real number okay and the next one is objective okay you set the objective function and constraint okay My question is, can we, well, switch, can we swap this objective with constraint? Can we change the flow? Can we put constraint before objective function? Can we declare the constraint before objective function? Yes or no? Yes, we can do it. Okay. But you cannot put your constraint before decision variables. Okay. Because we have to declare the decision variable first. Without proper declaration of decision variable, you see that we reference the x and y in objective function and constraint. Okay. So you declare it first before we use it. Okay. What else? And the other thing is you cannot solve before you declare this variable, objective function and constraint. Okay, this is straightforward, right? It's clear. And this one, you to know the value of x and y and also objective function. Well, you print out this value. Okay. And okay, so now I think you can run your, you can solve your optimization problem using PyMo. Okay, this is the code, piece of code. The next one is we declare the decision variable as non-negative real, right? What about integer? If you want to, well, treat the decision variable as integer or binary, you use this domain. Okay, for binary, you declare domain is pio.binary. Okay, and what about integer? For integer, you set as pio integer. Okay, or non-negative integer, depends. Okay, it depends. You know the difference between binary and integer, right? For binary, the variable can take only 0 and 1. Okay. For integer, integer is integer. Okay, it can be 0, 1, 2, 3, 4, 5, and so on. Okay. And for non-negative, it's clear. Non-negative is non-negative. It cannot take the negative value. And for continuous variable, of course, we use real. Okay. And for non-negative, real. Yeah. That non-negative reals. Okay. Try to find, go back to your code and try to find where should we replace. You found it? You found it, right? You know where to change in the code, right? Okay. Okay, good. And what about solver? Solver. PyMo delegates to an external MILP solver. Okay, so a common choice is ZBC, IceGLPK, Gurobi, or Cplex. Gurobi, it's commercial software. So if you want to run Gurobi, you need license. You have to apply for a license first. Of course, you can run using this one, Colab. Even Gurobi, you can run using Colab. But you have to download the license first and then put the license inside the Colab. Okay, I will show you later how to do that. Okay, but now you can use CBC and GLPK. Okay. Okay, the next code is You can read this code, right? This is also a very simple optimization problem. What about the first line? Do we need the first line? Import Primo.environment as Pio? Yes, you need every time. If you don't declare this, you cannot use the second line, okay? You have to import it first. And what about this? Products, cap, profit, demand, fixed cost, okay? It's parameters we use in our objective function problem. And yeah, we declare P, Y, X, okay? And you see we declare the domain as binary and non-negative real, okay? Then we set the objective function. Objective function is profit minus fixed cost, okay? So we sum the profit times with MXP. What is MXP? MXP it's M, not the profit. This is production quality or quantity, sorry. Okay, MXP. For P in MP, what does it mean? It's this is the kind of what is it? Python code. Okay, Python command. It's changing P in MP and then wow, sum up all this. Okay, and subtract by this one. Fixed cost. Okay. Okay, so let's check my Colab first. If I finish all this code. Oh, okay. The second block in the yeah. I gave you already. This is the second block. Yeah. This block. Okay. You click this one. Well, I think you can run it. Okay. Okay. And this code show you this example show you how to treat the integer variable. familiarize yourself with Python, basic command of Python. Okay. Because later we will implement all these things. Okay, any questions, any problems? Who still cannot run? Yes? Pardon, you say again? Louder. I cannot hear.
I can we put this GLK and PK.
You cannot run GLPK?
I run, but this is the 0.
Oh, you got all 0, right?ใครรันแล้วได้คำตอบที่สุดๆทำไมเกิดเป็นศูนย์มันไม่ควรจะเป็นศูนย์มัน This one. Yes, what happened?
The same 0.
Okay. The result should not be 0. It must not 0. Must not be 0. Okay. Oh, I got all 0 also. Okay, let us check on different problem. Okay, so I haven't checked the result yet because that example it's well, it's just for showing you how to treat the integer number. Let us back to our previous problem. We will put this one. Okay. Now we try this first example. The problem I think this one you did it last time, right? Okay. Try to implement this problem. using Primo. Okay, then we can check. First, you handle each variables as real, non-negative real first. Okay, and then once you got you can compare your answer, your result obtained, your solution obtained here with the solution you obtained from Excel. Okay, and then you solve it again, but changing the type of this variable to be integer. Okay, and check the results again.
And for constraint, of course, we add constraint one by one. Machine 1, machine 2. And for this one, you see that I move YS on the right hand side to the left hand side. I recommend you to do that. Just leave only constant on the right hand side. Okay. This is lesser than or equal to. Solve the same way. Once you solve, you should obtain this value. X1, X2, X3, X4, YS, YU. Drop it.
Okay, now you can solve it, right? If you obtain the solution already, if you can solve it, if you solve this problem already, then we'll try to handle the x1, x2, x3, x4, and ys, yu as integer. So I solve it again by treating all these variable as integer. You see how I just simply change this part non-negative reals to non-negative integer. I use the same solver GLPK, and this is what I obtain, the solution I obtain. So you don't take a break. It's okay. I think you can solve it already, right? Also, there are two milestones to check. First, you got a result here. Okay, the results are identical to what we obtained from Excel, right? Yes, yes. Mhm. And once we change from non-negative real to integer, okay, and we solve it, we got the result, right? Okay. Okay, you finish at this point, right? The next one is, remember that last time we used Excel, we also obtained sensitivity report, right? Remember, right? The shadow price and also sensitivity of so many things. Can we obtain such a report in using Python? Yes, it is. You need this piece of code. Sorry. One more thing. Well, integer programming, you will not get sensitivity report. Okay, only the real. Okay, and for in order to obtain the sensitivity report, first thing before you solve the problem, you need this line model.dual pio suffix, well, direction pio suffix import. Okay, and this piece of code, you will get sensitivity report. Okay, it will check through each constraint. Okay, and calculate the sensitivity. You need the code, I can copy to somewhere and then I don't know how. Okay, I will paste it in chat. Okay. The first part is no, not this part. Just before solve, you need this code first. You see in the chat. And to obtain and once you solve it, you need this code to generate sensitivity reports. Okay, good. And do it by yourself. You can solve other problem by yourself. Yes, right? Okay, so we move to the next problems. For multi-period problem, you can do it by yourself, okay? We move to the next one. Knapsack problem. Okay, for knapsack problem, well, it's work like it's similar to TSP, traveling salesman problem. For example, this case, a company wishes to ship a number of crates. Okay, you have a number of crates, and well, from one place to other place. Yeah, from your source to destination, Toronto to Kitchener, something like that, in a freight container. And the crates are 6 possible types. Okay, there are 6 types. Each type of crate has a given weight in kilograms and has a particular retail value in dollar. Okay, shown in this table. Okay, for example, type 1, the weight is 30. Type 2, weight is 20. And the value is 60, 70. Okay, see on from this table. So we have more constraint. We have constraint on the following. You cannot send more than 10 crates of the same type in the container. Okay. And you can only send crates of type 3 if you send at least 1 crate of type 4. What does it mean? What does it mean? If you don't send type 4, you cannot send type 3. Okay. And at least one of the following 2 conditions has to be satisfied. There are 2 more conditions. You have to satisfy one of these. Okay. Either this one or this one. Total of at least 4 crates of type 1 or type 2 is selected. Or a total of at least 4 crates of type 5 or type 6 is selected. What does it mean? What does it mean? You need 4 crates of type 1 or type 2. Or you need 4 crates of type 5 or type 6. Okay? One of this must be satisfied. Okay? And the total weight allowed on the freight container is 1 ton, 1,000 kilogram. And our goal, okay? We want to design how many crates of each type to place in a freight container so that the value of the crates in the container is maximized. Okay? What do you want? What is our objective function? Maximize of what? Profit. Maximize value. Okay? Because value means profit. Okay? And we have these following conditions. Okay, you see, in summary, the company has to fill a shipping container with 6 types of crates, right? And each type has a weight and value, okay? Different weight, different value. And the goal is maximize total value without exceeding the container capacity, okay? And there are some rules, okay? Constraints must be satisfied. Okay, group work. From a group, well, we can split to 5 groups. Five group. How many of you? Then group of 3. Then 4 groups is enough. Okay. Yeah, 4 groups. And then, well, each group start from formulate the model first. Okay. Yes, start working now. 4 groups. 4 group mean, well, each group 4 or 5, right? Just 4. Just 4. Okay? Each group has 4 members. And you have 15 minutes on to finish the formulation. So, what is your first step? To formulate the objective function, you have to design your decent variables first, okay? What are our decent variables? Okay? Mhm.
มัดเป็นของขีดได้มากกว่าหนึ่ง
ไม่ได้
เราต้องเลือกไหมเอาไปขีดที่
อันนี้มันเคลียร์อยู่แล้วเพราะว่า objective function ของเราคืออะไร value มากสุด ใช่ ถ้าเราเซตมากกว่า 1 เราจะโซลแบบนี้ไม่ได้ มันจะกลายเป็น multi objective optimization
คือแล้วก็เป็นอายุมากสุดแล้วก็เกิดความใช่ก็
ใช่
เพิ่มเป็นของก็ตัวเองเป็นส่วนที่ผมเป็นรองส่วนไม่รู้ว่าจะเป็นคุณ We want to maximize the sorry. คือต้องบอกเลยนะว่าอย่าเพิ่งเขียนโค้ดนะ
Don't jump directly to Python. First, we have to formulate the problem first. Okay, set the objective, set the decent variables, and then write the objective function as a function of decent variables.
Yes.
There is no. I equates of time clear, right? And you said create.อันนี้ไม่ใช่อีเดียวนะครับว่าในความไว้เขียนไม่ได้วิธีการแพทเทิร์นใหม่ก็ต้องใช้ที่เองนี่เดียวมันก็เป็นจุดหนึ่งมาหรือว่าแต่ว่าถ้ามีอยู่ในที่ก็ให้แบบthe maximum number เอาสูตรไปคูณไปกันเส้นคูณก่อนแต่สูตรไปคูณตัวฟังก์ชันว่าสูตรตัวผู้บริการสูตรคูณฟังก์ชันโอเคมาที่นี่ เขียนแปลที่หัวครับ
formulation. We set up the decent variables. Xi. Xi is the number of crates of type I. Okay, we have x1 to x6. Okay, and it must be integer. Right? It should be integer, right? And we set up logical variable to handle the constraint. This constraint. At least one of the following two conditions has to be satisfied. I will show you why we need that. Why? Okay? But look at the objective function first. Objective function is clear. We have x1 to x6, so we multiply with the value, right? Sum up everything, so we got objective function. What about constraint? The first constraint is each type must be less than 10, right? Oh, this is the second one. Total weight first. Total weight is, this is total weight. Weight, well, weight of each type, and then you multiply it with the number of crates, right? Totally must be less than 1000. Okay? And each type must be less than 10. Okay? And the next one, you can only send x3 if you send x4. If you send type 4. Okay? That means if you don't send type 4, you cannot send type 3. Okay, so we write this way. X3 is lesser than 10 x4. What does it mean? If x4 is 0, what happened? X3 must be lesser than 0. It means it forces automatically X3 to be 0, right? And if we send one crate of X4, on the right hand side it will be 10, right? So X3 lesser than equal 10, which is true, right? Because each crate must be less than 10. What about we send type 4 two crates? What happened? On the right hand side it will be 20. X3 must be lesser than 20. It's okay because we handle X3 anyway by using this constraint. All right. Now we have two conditions, two more conditions to handle. Either this one or this one. Okay. So we set y decent variable. This one must be Boolean. Boolean is, what's it? Binary. It can take only 0 or 1. Okay. And what happens if y is 0? If y is 0, x1 plus x2 must be greater than 0. It's okay. But we force this one to be true. Because y is 0, then in this condition, it must be 4, right? What does it mean? x5 plus x6 must be greater than or equal 4. You check the constraint again. This is, yeah? Okay? This is the when the second condition is true. Okay? And if y is 1, y is 1, of course, x1 plus x2 must be greater than 4. And what about this? You relax on this, right? This constraint. No constraint on this because x5 plus x6 must be greater than 0. Okay? Hmm? Any questions? Okay, so now this is our problem, optimization problem. Okay, and you see that xi is integer, and y can take only 0 or 1 is binary. Now we implement it in no need to Excel. I mean you can use Pimo. Okay. I give you each group 15 minutes to complete this. Okay, to solve it. So which credit did the solver choose? Did the solver respect the special rule? How do binary variables allow us to represent logic? What happens if the weight limit increase to 1500?นี่ไง This is how we handle binary. Okay? Domain pio.binary.
หรืออันใดเนี่ยใดสุดอย่างน้อยก็เป็นจริงอ่ะสินะแต่ถ้าเป็นจริงก็สองอันได้ไหมได้ไม่ได้บอกว่าอันนี้หรืออันนี้ in the class I'm going to เป็นจริงทั้งคู่ก็ได้ Yes. Actually, technically, you would also not do such calculation. Yeah, we are in the same realm. Is it right? What makes it different? Yes. ไม่ดีไอ้แล้วก็Asian อะไรก็ลองแก้ดูแก้เป็นคนทองลองเปลี่ยนเป็นพลังอะไรก็เยอะมากคุยได้ไม่มาได้แต่ที่จากว่าเราไม่ได้ยาวนะครับกาแฟคิวเดินสุดเดี๋ยวมันเป็นหน้าสุก็อยากสังเกตเป็นผลว่าที่ไม่หาเท่าไหร่พวกมันจะไม่ได้ยินเสียงย้ายเนี่ยนะคือทางจิต x 3 ลบจิต x 4ไปแล้วแบบเป็นอย่างนี้ของฉันแต่ถ้าต้อง x 3 เป็น4แล้วถ้าติดมันเป็นอย่างนี้ลูกเห็นไหมตรงนี้โอเคตรงนี้โอเคไหมเราได้ไหมครับกับ solution ได้ Thank you.
Okay. You got result? Yes or no? Yes. Okay. What about this group? Yes. Okay. This group also, right? Any one of you got result? Hmm?มันเป็นลบอ่ะไม่บวกตรงนี้5 กับ 6อ่ะ5 มันบวก 6ไหมอ่ะโอเคใส่สตาร์ด้วยฮะ4 คูณโอเคลองรันดูได้เลยได้ไม่มีปัญหาเราไม่ระเบิดอยู่แล้วจะได้รู้ว่าเป็นไงโมเดล4y ยังไม่มีโมเดล4บรรทัดที่ไหนล่ะเมื่อกี้มันบอกบรรทัดที่เท่าไหร่ลาย22ครับไปเจอลาย22เขาไม่มีเลขบอกเลยลาย22ของผมเครื่องผมมีอยู่โอ้ผมต้องนั่งนับ22มันต้อง4 คูณโมเดล 4y เนี่ยไม่มีโมเดล 4y บรรทัดบนอ๋ออะไรครับได้มีคำตอบเลยใช่ไหมโอเคไม่เป็นไรครับเดี๋ยว4 คูณโมเดลเราผมไม่แน่ใจว่าโมเดลนี้จะถูกตัวที่เป็น4 คูณ100กว่าถูกแล้วครับบวกแล้วก็ลบย้ายนั้นมาลบนะเขียนอย่างนั้นเลยใช่ไหมได้เขียนอย่างนั้นก็ได้ครับไหนเริ่มจาก no yu อยู่ไหนผมใส่ yu มาด้วยเหรอต้องไล่ลบไปตรงปริ้นมั้งตรงเนี้ย yu is เนี่ยปริ้นเนี่ยข้างล่างตรงนี้ก็ด้วย yu นี่ก็หายไปเลยโอเคลองดูถัดไปอะไรต่อ yu อยู่ยังมี yu อยู่ โมเดล6ตรงนี้ได้อยู่เลยโอเคลองรันดูยังไม่ได้คำตอบเดี๋ยวต้องไปเช็คดูว่าเกิดอะไรขึ้นนะครับโอเค so we have 2 activities so we don't have much time on that first group which grade did the server choose yes so tell me in order 0 and number 2 first one is 10 okay 0 7 okay how much do you get 1 9 3 0 okay this one right okay what about this group the same okay this one group 2 the same okay what about group 4 group 4 solution will it the same no what did you get 10 okay Huh? 10, 10, 10. 2, 0. And the last one, x6. What? Huh? Okay. What about objective function? 1 or 1, 8, 4, 0. Sorry, this one is greater. So what happened to your model? Check your model again. And this one we start, I don't know, what is it? Okay, what about you check each condition? The weight, what about the weight?
Weight is 990.
990, okay. And what about the second constraint? Is it correct? The second constraint, you remember the second constraint? Yeah, the next one, the next constraint. The next constraint, the third one. Yes, type 3, type 4. Is it correct? Is 3 and 4, right? But 0, it's okay. And what about last two constraints? About x1, x2, or x5 and 6, right? Yeah, this one greater, right? So should be okay. Okay, good. So the next question is, what happened if the weight limit increased to 1,500? Very simple, right? You just revise your model, one place, and then solve again. You got result? Change the constraint weight limit, increase to 1,500. How do you get? 10, 10, 7, 1, 0. 10. Okay. You get the same result? Okay. You see that because we cannot go beyond 10, right? So it's maximum at 10. Okay, good. So you got the same result? Change it to 500. Okay. 1,500. Group 4. What about group 4? You catch us? Huh? You follow us? Got some result? The first one, you check your model, right? Again? Okay. So, you see that knapsack problem, kind of classic combinatorial optimization problem, actually. Yeah. And now you learn how to handle integer and binary. Okay. You handle it, right? Integer and binary. Okay. And the difference between PLP and mixed integer program, MIP, you can try later. You can relax that integer. Number of crest, you can change it to real, non-negative real. And you see the difference, okay? Okay, so you got all these things already, right? You know how to handle integer binary and also solve it as a integer programming. Okay. Now we move to the next problem. The next problem is production and procurement planning. And you can expect that this one also multi-period optimization problem again. Okay. So Food is manufactured by refining raw oils and blending them together. Okay, and the raw oils are of two categories: vegetable oil, WEC 1, WEC 2, or mineral oil, oil 1, oil 2, oil 3. Okay, you have two types, and each type has two types. Okay, and this one has three types: oil 1, oil 2, oil 3. Okay, and each oil may be purchased for immediate delivery. Okay, let's say January, or we bought it on the future market for delivery in a subsequent month. And price at present and in the future market are given below. Okay. Okay. So we have 6 months. Let's say this first is one is January. You have January to June. Okay. And you have price for week 1, week 2, oil 1, oil 2, oil 3. Okay. Shown in this table. And the final product sells at this price, $150 per ton. Okay, this is your final product. You have only one product. Of course, you purchase 5 types of oil: WEC 1, WEC 2, oil 1, oil 2, oil 3, and you blend or refine it and make it your product. Okay, vegetable oil and non-vegetable oil require different production lines. Okay, different process for refining. In any month, it is not possible to refine more than 200 tons of vegetable oil and more than 250 tons of non-vegetable oils. Okay? And this sentence, this clause set constraint. Okay? And there is no loss of weight in the refining process. Okay? We assume that no loss of weight. Okay? No loss during processing. And the cost of refining may be ignored. Okay, we don't care about the cost for refining. It is possible to store up to 1,000 tons of each raw oil for use later. What does it mean? You can purchase raw oil, WEC 1, WEC 2, oil 1, oil 2, oil 3 now and use later. Okay, you keep it in the storage tank. The cost of storage for vegetable and non-vegetable oil is similar. It's identical. It's $5 per ton per month. Okay? And the final product cannot be stored. What does it mean? You refine it and you have to sell it. You cannot store your final product. Okay? What else do we have? There is a technological restriction of hardness of the final product. Your final product, the hardness of your final product must lie between 3 to 6. Okay? And we have hardness of each type of oil. Okay? And we assume that it's linearly blend. Okay? You just linearly interpolate of the raw material to get the to calculate the hardness of the product. Okay? So our question is buying and manufacturing policy. Okay? What buying and manufacturing policy should the company pursue in order to maximize profit? Okay? We assume that at present there are 500 tons of each type of raw oil in storage tank, in the storage tank. And it is required that this stock we also exit at the end of June. Okay? So again, group activity, but we will skip the problem formulation. So a factory must satisfy monthly demand for a single product over, no, not 4 periods, 6 period, right? Sorry, 6 period. And it can produce in-house at a limited capacity with production cost. It can procure externally with higher. Oh no, this is not correct. I mixed between 2 or 3 problem together. Just skip that. Okay, so we formulate it first, formulate the problem first, and then we model it and solve it. Okay. So, and then later we will. We don't have. I haven't formulated problem yet. So you have to formulate by yourself. So what about the distant variable? Okay, take I think 10 minutes to discuss in your group about the structure of the distant variables. What should we say that the distant variables? At each month, think about each month first. Purchase of each type. So let me set this way. No, purchase should be P. Okay. P. Yes. I, J. Okay. What is I? I should be, well, it depends. Month or type. What do you want? Is it type? Okay. Type. Week 1 is 1. Week 2 is 2. Oil 1 is 3. Okay. 4, 5. Okay. So it's running from 1 to 5, right? And J is month, right? At the beginning of that month. Okay. So it should be 1 to 6. Okay, good. What else? Remember that always think about this one is multi-period optimization problem. Storage tank. Okay, so we have our tank. In our tank, at the beginning of the month, each month, we have IJ again, right? TIJ. And what else? What else? What else? You have, wow, inside the tank, you have, wow, your purchase, your product, sell, can be sell, okay? Actually, we can write as IJ the same. But remember that in each month, you refine week 1, week 2, week 1, week 2, I1, I2, I3, and blend it together. Okay? So your product is a summation of S1 to S5, right? S1J to S5J. Okay? Okay, good. So what about objective function? Objective function is, what is objective function? Profit. We don't subtract it with cost because do we subtract it with cost? Yes, right? Because raw oils at each month are different, right? But no processing. Okay? So the objective function should be, you want to maximize it, right? Max. Okay. And each month we have P, no, sorry, S, I, J. Okay. What else? You subtract it by purchase. PIJ, right? Agree. Okay. What else do we have? Storage cost. And what about storage? This one should be, sorry. Well, let's finish this one first. Sij subtract by Pij. No, sorry. I confusing it. Oh, let's finish each term. Sij first, because Sij is, we have to time it with 150. Okay. Actually, you should sum it first. Sum by I and sum by J, right? You can sum by J. Yeah, it actually is the same. Okay. Sij. Okay. This one, sum by I means, well, because you're going to blend week 1, week 2, I1, I2, I3 together at each month, and you sum every month. And because the price for your final product is the same, you time it. Okay. And you subtract it with purchase. This is quite tedious work because you have each month it's different, right? So you have to, well, the cost, let's say Cij times with Pij, okay? It's position to position multiply, okay? And you sum everything J. Okay, agree? What about next? Subtract by 0.5. 5 or 0.5? 5. 5, right? Okay, it should be 5. 5 of sum J I P I J. Okay, agree? we have 3 decent variable, but it is, they are all matrix, okay? What about constraint? What do we have? What about constraint? Let us check one by one, yeah. No availability limit on each oil, right? So no limit on oil purchasement. And what else? We have capacity of the refining process. Okay? Right? What's it? For week 1 plus week 2 must be less than 200, right? What is this? Focus on cell. 1J plus S2J must be lesser than or equal to 200, right? And you have, well, J must be 1 to 6, right? Each month. Okay. And for 3 plus $250, you have 6 constraints. 6 constraints of this. Okay. What else? It is possible to store up to 1,000, right? So Tij must be lesser than or equal 1,000, okay? And this one, J must be 1 to 6 and I must be 1 to 5. Okay? Let that be strong. We also have hardness. For hardness, what is it? For each month, say 1 to 6, okay? (8.8) of S1J plus 6.1. 6.1 of 2J, right? Plus 2.0 plus 4.2 and the last one 5.0. Okay, 5J divided by S1J plus S2J plus S3J plus S4J plus S5J must be lesser than 8 point, huh? No, 6. Okay, 6. And this must be greater than 3, right? And you see that if you formulate your constraint like this, you render this constraint as nonlinear function because you divided variable by variables, right? So what should we do? We know that this one will not be zero and will not be negative, right? So we times both sides of equation by this term. Okay? So you multiply this term here and here, and you got two constraints for each line. Okay? And it is linear function. Okay? Your time is here. Okay? Time is here. Okay? And then this constraint become linear constraint. Finish? Not finished yet, right? What else do we need? We need, what is it? Material balance. I don't have space there. Right here. What for each month, say from 1 to 6, what we purchase at that month, Ij. Okay? Plus, it's not correct to write this way. I will tell you why, but it's okay. We write this first. What in the tank? Okay? Equal what we sell plus what remain in the tank next month. Okay? But you see that the problem occurs because it's j plus 1. If j is 6, we don't have ti7. Our decision variable has only 6. Okay? So we can have this kind of constraint only when j from 1 to 5. J from 1 to 5. Okay? So we will handle the last one separately. Okay? So it's P, no, right here. You can see from the back, right? Okay. PI 6, okay? Plus TI 6, okay? Equal SI 6, right? Plus 500. Okay? Because we have to put it back to the storage. What else do we have? Do we need? Remember that at the beginning, TI 1, it's 500. Okay? You start from 500 in the tank at the beginning of the month. And all of these PTS must be non-negative. From the table, you define it. You define it by yourself from this table. From this table. 6 months. Okay? 5 type. คูณก่อนคูณให้เสร็จก่อนแล้วค่อยมาซ้ำ don't function by position of C and P first and then you sum. It's not metric multiplication, it's point by point. Okay? You clear with the problem formulation? I believe that you can solve by yourself. Using Excel or using Python, you can solve it. Okay, so try to work as a group. Of course, you can work while this evening or tomorrow. Well, whenever you're available. Each group report how much they produce. I mean, the company produce and buy in each period. Okay, and how much inventory they keep. Compare strategy. Does inventory reduce cost when it's procurement used? And what else? And answer this. What happens if production capacity increased by 10 units? What does it mean? Remember that for vegetable oil, we set the limit at 200, right? For non-vegetable oil is 250. What about it's increased to 210 and 260? Okay. What if procurement cost drop below production cost? And what if storage cost is double? Okay. Try to resolve the problem and answer on this thing. Okay. When does it make sense to produce more than demand and hold inventory? Okay. In which period did the procurement become necessary and why? Is it always cheaper to produce than to buy? Or can storage cost flip that decision? Okay. Try to think about it. And this problem, don't use integer. It's a real number, okay? Non-negative reals. It doesn't make sense if you buy it as an integer. Okay. Also discuss which cost dominates. Total production cost, procurement cost, or inventory cost. Okay. If you were the factory manager, what's the key takeaway from your model? What real world uncertainties? For example, demand change, supplier delays would make this model more complex. Okay, try to think about it. Of course, we don't have this information, but yeah, if we have uncertainty, what are we going to do? Okay, right. I will put this slide. I will update this slide in my course view. And yeah, this is the last one. Feedback. Okay. And we finished today. Okay, we finished today.